Okay, welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. We're going to do wave behavior of light in nature. Quick review, look over here. We're going to do a quick line spectrum using the Broglie Equation. So take the problem where we were trying to find the energy, the E value for when an electron jumps from the third to the fifth when we get the dark line spectrums. Pause it, work through it. Answer you should get is right there, 1.550 times 10 to the negative 19th joules. All right, now, a long time discussion took place in chemists. Light. Is light a particle or a wave? Now, the actual answer is yes. It's both a particle and a wave. It's got a wave nature, so light travels in a transverse wave function like that. But there are particles inside of there, electrons usually are the particles inside of there. They measure in units of photons. So to find the way that the light moves in terms of speed and all that, we get what's called the Broglie Equation, which states that the wavelength is equal to h little hat on top of it over mv, where lambda, of course, is wavelength. That h little is Planck's constant. M is the mass of the particle, and V is the velocity of the electrons. So, let's take a look at the problem here. We also need to know the mass. Now, we're going to usually use electrons because that's what's inside there, but just for kicks and giggles, do know that the mass of a neutron is right there, mass of a proton, just to see if we can throw those in there and mess with you a little bit, get you to understand. All right, so let's take a problem. Calculate the wavelength of an electron traveling at 5.220 times 10 to the 6th. Those electrons are really moving meters per second. All right, so we use our Broglie equation. We don't know the wavelength that you're trying to find. Planck's constant, of course, is still 6.63 times 10 to the minus 34th joule seconds. It's 9.10938.215 times 10 minus 31st. We go back to that last page there. That's a mass of an electron. It says electron, and the velocity is 5.220 times 10 to the 6 meters per second. So plug our values in. Now we got to cross some things out here. All right, we're going to cross out, and we get rid of joules by using the equality at 1 kilogram is a meter squared per second squared. I'm sorry, a joule is a kilogram times meter squared per second squared. And then a meter is equal to 1 times 10 to the 9th nanometers. So put those in there. When we do, joules cross out, meters, both of them cross out, seconds, both of them cross out, kilograms cross out. With nanometers, take 6.63 EE minus 34 times 1 EE9 equal, divide by 9.10938.215 EE minus 31 equal, divide by 5.220 times 10 to the 6 sig figs. The only sig figs we actually have here, because this is a constant, and this is actually a constant, so we have 4 sig figs. To 4 sig figs, the answer is 0.1394 nanometers, and you wouldn't be able to see that. That's invisible light. All right, let's try another one. This time I want to determine the speed of an electron if the wavelength is 534.10 nanometers. So this we can see. We're going to probably be green, orange in there someplace of the spectrum. So our equation again, our values, lambda 534.10 nanometers, Planck's constant, doesn't change. Mass is still an electron, so there's a mass of electron in case you don't believe me. All right, and we don't know the velocity. So we're going to rearrange. We're going to swap partners. V is going to go up, lambda is going to come down. So we're going to get V is equal to Planck's constant over m lambda. Put the values in with our other two. Joules are going to cross out. Meters, 1 meter crosses out. 1 nanometers crosses out. 1 kilogram crosses out. 1 second cross out. We're left with meters per second. Take 6.63 EE minus 34 times 1 EE9 equal, divide by 9.10938.215 EE minus 31 equal, divide by 534.10 EE sig figs. Again, we're going to be right here, 5 sig figs, because all the rest of these are constants. To 5 sig figs, you should get 1,372.7 meters per second. Not nearly as fast, 62.7. As the other one. That's why the wavelength was shorter, But again, this is still moving pretty good. All right, let's do one last one. Now, remember I said just to see if we can mess with you, I want you to determine what kind of particle it is. Is it a proton, is it a neutron, is it an electron? Just to see. For a type of particle in emission, the wavelength is 442.61 nanometers, and the velocity of the wave is 0.89555 meters per second. Okay, just pause the video, work through it. LTSWPD, any questions, gmail.com. Like, share, subscribe, comment, all that good stuff. All right, ready? Here's the answers. It's 1.6726 times 10 to the minus 27th kilograms. It's a proton. All right, that's it. Not too bad. Take care. God bless.